The thermometer inside Jeremiah Fox's red clay cave read 69 degrees Fahrenheit on August 15, 1854, while the outside temperature soared to 113 degrees, hot enough to kill cattle where they stood. 6 months later, during the January blizzard that froze the Arkansas River solid, the same thermometer still read 69 degrees, while neighbors burned furniture to avoid freezing to death in their wooden cabins. Drop a comment with your location and hit that subscribe button for more incredible stories from history. The rescue party from Fort Scott expected to find another frozen corpse when they reached the red clay cliffs overlooking Walnut Creek on February 28, 1855. The worst winter in Kansas Territory history had claimed 43 lives in surrounding settlements, with temperatures plunging to minus 30 degrees for 2 consecutive weeks. Captain Marcus Hayes led his men toward what locals called, quote, zero, a cave dwelling carved directly into the distinctive red sandstone formation that dominated the valley's western edge. What they discovered defied comprehension. Through a perfectly fitted wooden door set into the cliff face, warm air flowed steadily, carrying the scent of baking bread. Inside, they found Jeremiah Fox tending a small garden of winter vegetables illuminated by soft light filtering through translucent panels. The temperature felt like a pleasant spring day. Fox greeted them calmly, offering fresh turnips from plants that shouldn't have survived in any Kansas winter, let alone this killing freeze. The cave's interior revealed careful engineering rather than crude excavation. Smooth walls curved gracefully into vaulted ceilings. Multiple chambers connected through arched passages that seemed to breathe, pulling fresh air through the space without creating drafts. The red clay itself radiated gentle warmth absorbed during summer months, releasing it slowly through winter. Most remarkably, condensation channels carved into the walls collected moisture and directed it to ceramic containers, providing fresh water without venturing outside. Hayes's men explored in amazement. The sleeping chamber maintained perfect comfort without any heating source. A food storage area kept vegetables fresh and meat preserved at ideal temperatures. The main living space featured furniture carved directly from clay walls, shelves laden with supplies, and that impossible winter garden thriving in boxes of transported soil. Everything suggested not mere survival, but comfortable living through conditions that had devastated conventional homesteads. The thermometer mounted on the living chamber wall drew particular attention, 69 degrees exactly, despite exterior temperatures that would freeze exposed skin in minutes. Hayes asked Fox how long the cave had maintained this temperature. Quote 1:1. Fox replied, quote, 2. Word of Fox's survival spread rapidly through military and civilian channels. Newspaper reporters, government officials, and curious homesteaders began arriving to witness the impossible, a dwelling that required no fuel for heating or cooling, maintaining perfect comfort through the worst extremes Kansas weather could deliver. But understanding how one grieving man had discovered these principles required going back 8 years to a tragedy that transformed Jeremiah Fox from conventional homesteader to revolutionary builder who let the earth itself become his shelter. December 3, 1847, started like any other morning in the Fox homestead 12 miles west of Independence, Missouri. Jeremiah had built their cabin using standard frontier methods, oak logs chinked with clay, a stone fireplace, and a shake roof sealed with pine tar. His wife Elizabeth nursed their 4-month-old daughter Mary while preparing breakfast. The stove blazed against an early cold snap that had dropped temperatures near zero, unusual for early December. Jeremiah was returning from the barn when he saw smoke, not from the chimney, but seeping through the roof boards near where stovepipe met wood. He shouted a warning and ran, but frontier fires moved faster than human comprehension. The pine tar ceiling, meant to waterproof, became an accelerant. The shake roof exploded in flames. By the time Jeremiah crashed through the door, the interior was already an inferno. Elizabeth had tried reaching the door while carrying Mary, but burning roof debris blocked her path. The heat drove Jeremiah back despite desperate attempts to push through. Within 4 minutes, the entire structure collapsed. He dug through smoking ruins with bare hands until neighbors arrived and pulled him away. They found Elizabeth and Mary together, mercifully killed by smoke before flames reached them. The sight broke something fundamental in Jeremiah Fox. The following weeks passed in a grief-stricken haze. Neighbors sheltered him, but Jeremiah spent days at the burned homestead, sifting ashes and studying failure. The fire had started where everyone knew fires started, where hot metal met dry wood. Standard construction invited disaster. Every cabin used the same vulnerable materials, the same deadly design. His family had died not from tragedy, but from predictable engineering failure. Spring 1848 found Jeremiah obsessively documenting cabin fires throughout the region. The Patterson family, 4 dead when chimney sparks ignited their roof. The Millers, suffocated when their door stuck, while smoke filled their cabin. Every wooden structure shared identical vulnerabilities, flammable materials, poor ventilation, and nowhere to escape when disaster struck. Traditional building meant accepting that families would periodically burn to death, but some structures never burned. Traveling to trade blankets, Jeremiah encountered limestone caves along the Kansas River where native tribes had sheltered for generations. These natural formations never froze in winter, never overheated in summer, and absolutely could not burn. The Kansa and Osage peoples spoke of caves that breathed like living things, maintaining perfect conditions regardless of outside weather. The revelation came while sheltering in such a cave during a spring thunderstorm. As lightning split trees and rain hammered the landscape, Jeremiah sat in perfect comfort within stone walls that had existed before human memory. No fire risk, no temperature extremes, no maintenance or fuel required. Nature had already solved every problem that killed frontier families. Humans simply insisted on building against natural principles rather than with them. Jeremiah Fox spent the summer of 1848 studying caves with scientific intensity. Unlike eastern limestone caverns, the formations along Walnut Creek featured distinctive red clay mixed with sandstone, a geological oddity created millions of years ago when ancient seas deposited iron-rich sediments. This red clay possessed properties that fascinated him. It felt warm in winter, cool in summer, and seemed to breathe moisture in and out with changing conditions. The Osage guides who showed him sacred caves explained what their ancestors had long known. Red clay held the sun's heat like no other material, absorbing energy during hot seasons and releasing it gradually through cold. The thermal mass principle wasn't understood in scientific terms, but indigenous peoples had used it for countless generations. They showed him chambers carved centuries ago that still maintained stable temperatures year-round. Jeremiah filled notebooks with observations. He measured temperatures at different depths, finding that just 8 feet into the clay, variations between summer and winter disappeared entirely. He studied how natural caves channeled air, creating convection currents that ventilated spaces without losing thermal stability. He noticed how curved walls prevented condensation buildup, how certain angles promoted air circulation, and how the clay's porosity regulated humidity naturally. The most significant discovery came from examining ancient tool marks. Previous inhabitants hadn't just occupied natural caves, they had enlarged and modified them. Chisel marks showed deliberate expansion patterns. Smoke residue indicated where fires had been positioned to heat mass rather than air. Drainage channels carved into floors showed sophisticated water management. These weren't primitive shelters, but engineered living spaces refined over centuries. By autumn, Jeremiah had identified the perfect site, a south-facing red clay cliff above Walnut Creek's floodline. The formation showed natural cavities that could be expanded. The clay tested pure, no unstable sandstone layers or water-permeable sections. The cliff face caught morning sun while trees provided afternoon shade. Most importantly, the site resembled successful indigenous caves he'd studied, suggesting similar thermal properties. His planning went beyond mere imitation. Jeremiah designed improvements based on frontier needs. Where ancient inhabitants created communal spaces, he planned private chambers. Where they relied on smoke holes, he conceived sealed ventilation systems. Where they accepted natural limitations, he imagined engineered solutions. The fusion of indigenous wisdom and frontier innovation would create something unprecedented. Local settlers thought grief had driven him mad when he announced plans to abandon traditional building, they whispered. But Jeremiah had seen too many cabins become death traps. He'd watched families freeze beside inadequate stoves and burn in wooden tinderboxes. If wisdom meant learning from those who had survived on this land for millennia, then he would gladly be called savage. The Journey to St. Louis in March 1849 took Jeremiah Fox into a world of industrial suppliers and specialized merchants who had never encountered his requests. While other frontier settlers bought axes and saws, Jeremiah sought tools for working stone and clay. At Morrison's mining supply, he ordered equipment that puzzled even experienced clerks: specialized chisels designed for soft rock, curved scrapers used by sculptors, and drilling tools typically reserved for quarry operations. His most unusual purchases came from unexpected sources. At a glassmaker's workshop, he bought sheets of mica, translucent mineral that could serve as windows while maintaining thermal barriers. From a jeweler, he acquired precision measuring instruments for ensuring perfect angles in carved spaces. At a ship chandler's, he found waterproofing compounds made from pine resin and beeswax, designed for sealing hulls but perfect for his planned clay treatments. The expense staggered observers. Jeremiah spent his entire savings from 5 years of farming, plus money from selling his burned homestead land. Where a traditional cabin might cost $50 to construct, his tools alone exceeded $300. Fellow travelers on the riverboat back to Independence openly mocked his purchases. Quote 5. One asked, examining the strange implements. Quote 6. Jeremiah replied quietly. Back in Kansas Territory, his preparations intensified local skepticism. Jeremiah constructed a workshop at the cliff base, protecting his tools and creating templates for planned excavations. He mixed experimental batches of sealants, testing how different compounds bonded with red clay. He practiced with each tool on loose rocks, learning proper angles and pressure for efficient cutting. Neighbors riding past saw him spending hours simply studying the cliff face, marking positions with chalk. The systematic approach revealed Jeremiah's transformation from grieving widower to focused engineer. He created detailed drawings of planned chambers, calculating cubic feet of excavation needed. He designed ventilation shafts based on chimney principles but adapted for horizontal boring. He figured load-bearing requirements for arched doorways. Every detail received careful consideration, from drainage slopes to storage alcove placement. Most innovative were his plans for thermal regulation. Jeremiah designed chambers with specific proportions to maximize thermal mass while minimizing excavation. He planned curved walls that would radiate heat evenly. He calculated the exact thickness needed between interior spaces and outside surfaces to achieve optimal insulation. His notebooks filled with heat transfer equations learned from engineering texts applied to red clay properties discovered through observation. By summer 1849, everything stood ready, tools sharp and organized, plans detailed and reviewed, site prepared and marked. Local sentiment had shifted from sympathy to ridicule. The community had decided Fox was deranged by grief, pursuing an impossible fantasy. But Jeremiah had spent 18 months studying why traditional building failed and how natural formations succeeded. Now came the test of whether one man could carve a better solution from solid earth. The first strike of chisel against clay on July 5, 1849, began 3 months of solitary labor that would transform Red Cliff into living space. Jeremiah Fox started with the entrance, a rectangular opening positioned where natural fractures made excavation easier. Unlike mine shafts that followed ore veins, his cuts followed thermal principles. He angled the entrance downward to trap warm air inside while allowing cold air to drain out, a design borrowed from prairie dog burrows. Progress measured in inches per day challenged patience. The red clay proved harder than anticipated when dry, requiring constant sharpening of tools. Jeremiah developed a technique of scoring patterns with pointed chisels, then removing material with broader scrapers. He learned to read the clay's grain, finding natural cleavage planes that made removal easier. Each bucket of excavated material had to be hauled out and dispersed to prevent entrance blockage. The first chamber took 6 weeks to complete. Jeremiah carved a perfect dome, 12 feet in diameter and 8 feet high, following indigenous patterns he'd observed. The curved ceiling distributed weight evenly, preventing collapse without support beams. He discovered that keeping walls slightly damp during carving prevented cracking and made smoothing easier. The finished surface, when sealed, would become nearly as hard as fired ceramic. Ventilation posed the greatest challenge. Traditional caves relied on natural air movement, but Jeremiah needed controlled circulation. He bored 2 shafts from the main chamber, one rising to emerge behind the cliff top disguised among rocks, another angling laterally to catch prevailing winds. The work required specialized augers and weeks of careful drilling. Breakthrough moments when shafts reached surface brought fresh air flooding in, validating his calculations. By September, neighbors occasionally climbed the cliff to observe progress. They found Jeremiah clay-caked and exhausted, but progressing steadily. The main chamber connected to smaller alcoves for sleeping and storage. Drainage channels in floors directed any moisture towards the entrance. Shelving carved directly into walls eliminated need for furniture. Most impressive were window openings where translucent mica sheets would install, providing light without compromising insulation. The physical toll showed in Jeremiah's appearance: weight loss, permanently clay-stained hands, and premature aging from exhaustive labor. But his eyes held determination absent since the fire. Each carved foot represented protection against flames that had stolen his family. Each smooth wall meant security from temperature extremes that killed settlers annually. The cave grew from grief-driven obsession into something more, proof that humans could build in harmony with natural forces rather than opposition to them. Local mockery peaked as autumn arrived. Quote 7, "Armed," became the common term, spoken with mixture of pity and derision. But Jeremiah continued carving, adding details that would prove critical: the curved air channels, the thermal mass calculations, the moisture management systems. Winter would test whether 3 months of labor had created shelter or simply an elaborate grave. October 1849 brought the critical phase of Jeremiah Fox's construction, creating walls that could breathe while maintaining thermal integrity. The raw carved clay needed treatment to prevent moisture damage and create the sealed yet permeable surface his design required. Drawing from shipbuilding techniques and indigenous practices, Jeremiah developed a revolutionary coating system that would make his cave genuinely habitable. The base treatment consisted of pine resin heated with beeswax and mixed with finely ground charcoal. Jeremiah applied this compound to carved walls using broad brushes made from horsehair, working the mixture deep into the clay's porous surface. The technique came from observing how native peoples waterproofed their dwellings, but he modified ratios for optimal penetration. Each coat required days to cure properly, during which the cave filled with aromatic resin scents. Multiple thin layers proved superior to single thick applications. Jeremiah discovered that building up the seal gradually created a surface that repelled liquid water while allowing water vapor to pass, critical for preventing condensation buildup that plagued sealed spaces. The charcoal addition wasn't merely aesthetic, it created microchannels that promoted vapor transmission, while the resin wax matrix provided structure. The resulting surface felt smooth like polished stone, but remained slightly yielding to touch. The ventilation system received special attention during this phase. Jeremiah crafted adjustable baffles from thin cedar sheets, installing them at strategic points in his air shafts. These allowed regulation of airflow based on seasonal needs, maximum circulation in summer, minimal in winter. He discovered that coating the air channels with extra layers of sealant created smooth surfaces that promoted laminar flow, reducing noise while improving efficiency. Installing the mica windows marked a delicate operation. Each translucent sheet had to be cut precisely and seated in grooves carved into the clay. Jeremiah bedded them using a special mixture of his sealant compound with added limestone powder for rigidity. The windows weren't perfectly clear but admitted surprising amounts of diffused light while maintaining complete thermal barriers. Positioned to catch morning sun, they would provide natural illumination without heat gain. The quote 8 represented Jeremiah's most innovative feature. He carved a specialized chamber connected to the main space through a curved passage. This chamber, left unsealed, maintained direct contact with the clay mass. As external temperatures changed, the clay expanded or contracted slightly, creating pressure differentials that drove air exchange. The system breathed literally, inhaling fresh air when cooling, exhaling stale air when warming. No mechanical parts, no maintenance required. By November's end, the treatment phase was complete. The cave's interior gleamed with a deep amber finish from the resin coating. Surfaces felt warm to touch, despite dropping external temperatures. Most remarkably, the space smelled fresh rather than musty. The breathing walls and clever ventilation created an atmosphere more pleasant than most wooden cabins. Jeremiah installed his salvaged furniture and prepared for winter's test. Neighbors making final preparations for cold months shook their heads at Fox's folly, but the cave stood ready to prove natural principles superior to conventional construction. The final phase of construction in November 1849 required Jeremiah Fox to seal his cave against water infiltration while maintaining the breathing capability essential to comfort. Red clay's porosity, while excellent for thermal regulation, meant potential disaster if water penetrated deep enough to freeze or caused structural erosion. His solution drew from multiple sources: ship caulking, adobe construction, and techniques observed in ancient cave dwellings. The exterior cliff face received primary attention. Jeremiah identified every natural crack and fissure above his excavation, filling them with a special compound of crushed limestone, clay, and pine pitch. This mixture expanded slightly when wet, creating positive seals that tightened with moisture exposure. He worked from ropes, dangling precariously to reach high sections where water might channel toward his entrance. Each sealed crack received multiple coats applied in different weather conditions. The entrance presented unique challenges. Jeremiah constructed an overlapping threshold system inspired by ship hatches. Water running down the cliff face would encounter 3 separate barriers before reaching the door. He carved channels that directed flow away from the opening, incorporating natural rock formations into an integrated drainage system. The wooden door itself, built from seasoned oak, seated into grooves packed with waterproof oakum and sealed with his resin compound. Inside, Jeremiah applied different strategies for different chambers. Storage areas received heavier sealing to prevent spoilage from humidity. Living spaces maintained lighter coatings that maximized the clay's natural humidity regulation. He discovered that leaving strategic sections unsealed created moisture reservoirs. During dry periods, these areas would release humidity into living spaces while absorbing excess moisture during damp seasons. The system self-regulated without mechanical intervention. The roof sections above chambers demanded special care. Jeremiah bored small drainage holes at angles that prevented direct water entry while allowing trapped moisture to escape. He packed these holes with graded gravel that filtered runoff while maintaining airflow. The technique came from studying how prairie animals prevented burrow flooding. Multiple small drainage points worked better than single large ones. Testing revealed unexpected benefits. Water striking sealed surfaces created natural cooling through evaporation, enhancing summer comfort. Winter ice formation on exterior treatments added extra insulation without damaging underlying clay. The breathing walls continued functioning perfectly, with moisture passing through sealed surfaces as vapor, while liquid water remained excluded. Jeremiah's multi-layered approach had created an envelope that protected while preserving natural regulation. By December 1, 1849, the cave stood complete. Every surface treated, every potential leak addressed, every system tested. Jeremiah moved his salvaged possessions inside permanently, abandoning the temporary shelter he'd occupied during construction. Neighbors making final winter preparations noticed smoke no longer rose from Fox's temporary camp. He had committed fully to his experiment. The coming winter would prove whether grief-driven innovation had created genuine improvement over traditional building or merely an elaborate tomb. December 1849 arrived with unusual severity, bringing immediate validation of Jeremiah Fox's unconventional dwelling. The first blizzard struck on December 10th, dropping temperatures to -15 degrees and depositing 2 feet of snow. While neighbors struggled to maintain fires hot enough to combat the cold, Jeremiah discovered his cave required no heating beyond a small cooking fire. The thermometer he'd mounted on his living chamber wall read 68 degrees, 1 degree below his calculated ideal. The thermal mass principle proved more effective than even Jeremiah had anticipated. Months of summer heat stored in thousands of tons of red clay radiated gently into living spaces. The sealed walls prevented heat loss, while the breathing mechanism maintained fresh air without drafts. Most remarkably, the temperature remained constant. Whether outside temperatures hit -20 or climbed to 20 above, the interior varied by only 2 or 3 degrees. Neighbors initially refused to believe reports from traders who'd visited Fox's cave. William Harrison, whose cabin sat 2 miles away, lost 3 toes to frostbite that winter despite burning enormous quantities of wood. When he finally accepted Jeremiah's invitation to visit, he found the cave owner working in shirt sleeves, vegetables growing in boxes near the mica windows, and no heating stove in sight. "It's warmer than my cabin at full fire," Harrison reported incredulously. The cave's systems performed flawlessly through winter's worst. The drainage channels Jeremiah had carved handled snowmelt without flooding. The sealed entrance never froze shut, a common problem with traditional doors. The ventilation system adjusted naturally to pressure changes, increasing flow during clear high-pressure days and reducing it during storms. Even the mica windows exceeded expectations, admitting enough light for reading while frost formed on exterior surfaces. Jeremiah documented everything meticulously. He recorded daily temperatures inside and out, tracked humidity levels, and noted any maintenance requirements. The data revealed patterns. The cave responded to external temperature changes with a 12-hour delay, smoothing out daily variations completely. Humidity stayed between 40 and 60%, regardless of outside conditions. Air quality remained fresh even with entrance sealed for days during blizzards. The psychological benefits proved equally significant. While neighbors battled constant anxiety about fuel supplies and structural integrity during storms, Jeremiah enjoyed peaceful security. He slept soundly through howling winds that kept others awake, fearing roof collapse. He maintained regular routines impossible in cabins, requiring constant fire tending. The stable environment allowed activities like food preservation and craft work that fluctuating temperatures made difficult elsewhere. By winter's end in March 1850, the results were undeniable. Jeremiah had consumed no fuel for heating, suffered no weather-related damage, and maintained better health than traditionally housed neighbors. Several families who'd lost members to pneumonia that winter noted bitterly that Fox hadn't even caught a cold. The cave that had provoked ridicule now prompted serious interest. How would it perform in summer's opposite extreme? June 1850 brought the first test of Jeremiah Fox's cave during extreme heat. As temperatures climbed past 100 degrees by mid-month, a brutal heat wave settled over Kansas territory. Livestock died standing in fields. Wooden cabins became unbearable ovens that families abandoned for shade trees. The conventional solution, opening all windows and doors, provided no relief when outside air felt like furnace blast. Inside the red clay cave, Jeremiah's thermometer held steady at 70 degrees. The same thermal mass that had radiated warmth all winter now absorbed excess heat, maintaining comfortable conditions without any cooling mechanism. The breathing walls pulled hot air up and out through upper vents while drawing cooler air from shaded entrance areas. The system required no operation. Physics handled everything automatically through density differentials and convection currents. The revelation came when Jeremiah realized his cave performed better in extreme heat than extreme cold. Winter temperatures inside had stayed slightly below his target, but summer temperatures hit his calculated ideal precisely. The red clay's specific heat capacity meant it absorbed daytime heat slowly, releasing it at night when external temperatures dropped. This daily cycle created perfect stability, unlike wooden structures that heated rapidly and retained nothing. Curious neighbors began visiting as the heat wave persisted. Martha Williamson, 8 months pregnant and suffering terribly in her stifling cabin, spent afternoons in Jeremiah's main chamber. "It feels like spring in here," she marveled, while outside temperatures reached 108 degrees. Her husband Thomas studied the ventilation system intently, trying to understand how air moved without bellows or fans. The agricultural implications astounded everyone. Jeremiah successfully stored milk and butter without spoilage, impossible in traditional root cellars during such heat. Fresh vegetables lasted weeks instead of days. Meat properly smoked and stored showed no signs of decay. The stable temperatures and humidity created natural preservation conditions that mechanical refrigeration would later struggle to match. Several families began bringing perishables for storage, offering payment Jeremiah refused. Most impressive was the cave's performance during temperature swings. July brought days when morning temperatures started at 60 degrees and afternoon highs exceeded 100. These 40-degree variations destroyed food, stressed livestock, and made humans miserable in conventional dwellings. Inside Jeremiah's cave, temperatures varied by less than 2 degrees throughout the day. The massive thermal buffer smoothed out extremes completely. By August, even former mockers acknowledged Fox's achievement. The cave that couldn't possibly work had now proven superior through opposite seasonal extremes. Engineers and educated visitors struggled to explain principles that Jeremiah had discovered through observation and intuition. The grief-driven project had become a demonstration of how working with natural forces rather than against them could create superior living conditions using no fuel, no complex mechanisms, and no ongoing maintenance. Interest in replication grew, but few understood the careful planning required. September 1850 marked Jeremiah Fox's decision to expand his proven cave system. The original chambers had performed beyond expectations, but limitations emerged. Storage space proved insufficient for year-round food preservation. The single living area became cramped when visitors stayed during weather extremes. Most significantly, Jeremiah envisioned demonstrating agriculture possibilities that current space couldn't accommodate. Expansion would prove his concepts scaled beyond personal shelter. The expansion plan reflected lessons learned. Jeremiah designed 3 new chambers connected by curved passages that promoted air circulation. Each served specific purposes: extended food storage, workshop space, and an ambitious agricultural chamber with enhanced natural lighting. He positioned new excavations to maximize thermal mass while minimizing structural weakness. Every cut followed natural clay formations, working with geological patterns rather than imposing arbitrary designs. Excavation proved easier with experience. Jeremiah had perfected techniques for reading clay grain, identifying optimal removal sequences, and maintaining structural integrity. He developed specialized tools during the original construction: curved scrapers that followed his chamber profiles, measuring guides ensuring consistent dimensions, and water misting systems that controlled dust while optimizing working consistency. The second phase progressed 3 times faster than initial construction. The agricultural chamber represented Jeremiah's boldest innovation. He created a space 15 feet wide with a sloped ceiling reaching 12 feet at its highest. Along the south-facing wall, he installed a series of mica panels at angles calculated to maximize light penetration while minimizing heat gain. The design drew from greenhouse principles but adapted for underground application. Reflected light from white-sealed walls increased illumination throughout the space. October brought unexpected discovery. While excavating the storage chamber, Jeremiah broke through into a natural cavity containing an underground spring. Clear water seeped from limestone layers above the clay, creating a permanent water source inside his dwelling. He carefully enlarged the opening and carved collection basins, incorporating the spring into his expansion design. The constant 50-degree water provided cooling potential and eliminated hauling water from Walnut Creek. Integration work proved as critical as excavation. Jeremiah connected new chambers using his proven sealing techniques, ensuring the breathing mechanism extended throughout the expanded space. He adjusted ventilation shafts to accommodate increased volume, adding control baffles that balanced airflow between chambers. The spring chamber required special drainage to prevent flooding while maintaining humidity benefits. Every detail reflected systematic thinking about how spaces would interact. By November 1850, the expanded cave encompassed over 2,000 square feet of living space. The agricultural chamber already showed promise. Late-season vegetables thrived in consistent temperatures with filtered light. The spring provided reliable water for irrigation and consumption. Storage chambers maintained different temperatures based on ventilation settings, creating zones for various preservation needs. Workshop spaces allowed year-round crafting impossible in temperature-variable structures. The completed expansion transformed Fox's personal shelter into something approaching a demonstration facility. Visitors could see applications beyond individual dwelling: community storage, protected agriculture, craft production. The cave system proved natural building principles worked at any scale with proper planning. The summer of 1851 brought the most severe heat wave in recorded Kansas Territory history. By July 15th, afternoon temperatures exceeded 110 degrees for 7 consecutive days. Wells ran dry. Crops withered despite irrigation. Most devastating were livestock losses. Cattle, horses, and pigs died by dozens, their bodies bloating in heat that made burial impossible. Traditional cooling methods failed catastrophically as families watched their livelihoods perish. Thomas Garrett, who had mocked Fox's folly most vocally, lost 18 head of cattle in 3 days. His milk cow collapsed in the barn, despite constant water and shade. Desperate to save his remaining prize bull, Garrett swallowed pride and approached Jeremiah Fox. "Can your cave hold livestock?" he asked. Within hours, Garrett was leading his bull down the carved entrance ramp into cool chambers where the animal immediately revived. Word spread rapidly. By evening, 3 more families had brought their most valuable animals. Jeremiah's expanded chambers, designed for storage and workshops, became temporary stables. The constant 70-degree temperature that had seemed miraculous for humans proved equally effective for animals. Cows that hadn't given milk in days resumed production. Horses that had stood listlessly in killing heat regained energy. The underground spring provided unlimited water. Martha Williamson arrived next, carrying her infant son born during the previous summer's heat. The baby had developed heat rash and cried constantly in their stifling cabin. Within an hour, in the cave's cool air, he slept peacefully. Martha's tears of relief prompted her husband Thomas to finally admit what pride had prevented. Fox had discovered something revolutionary. By week's end, 15 families were rotating through the cave chambers. The social dynamics shifted dramatically. Men who had ridiculed Jeremiah now studied his construction techniques intently. Women who had pitied the crazy widower now begged to learn food preservation methods that the cave made possible. Children played in chambers where consistent temperatures prevented the exhaustion that plagued them in conventional homes. The cave became an impromptu community center, necessity overcoming years of mockery. Jeremiah handled the invasion gracefully, organizing schedules to accommodate everyone while maintaining order. He demonstrated water collection from the spring, showed optimal storage arrangements for different foods, and explained ventilation adjustments. Most importantly, he began teaching construction principles. Using charcoal on smooth walls, he diagrammed thermal mass calculations, airflow patterns, and excavation sequences. Former skeptics took careful notes. The heat wave broke on July 25th with violent thunderstorms that flooded conventional root cellars. Families retrieving stored goods from Jeremiah's chambers found everything perfectly preserved, dry, cool, and fresh. The contrast with spoiled supplies in their own storage convinced remaining doubters. Thomas Garrett summarized the conversion. Quote 14. Professor Edmund Hartley from the Missouri Scientific Institute arrived at Jeremiah Fox's cave in October 1851, drawn by reports that challenged conventional understanding of thermodynamics. The Princeton-educated geologist expected to find lucky accident or exaggerated claims. Instead, he discovered engineering principles that wouldn't be formally codified for decades. His subsequent report transformed academic understanding of indigenous building wisdom and natural climate control. Hartley spent 3 weeks conducting measurements and calculations. He determined the red clay's specific heat capacity exceeded most building materials by factors of 4 to 5. The iron oxide content that created the distinctive color also enhanced thermal properties. More remarkably, the clay's microporosity created perfect moisture regulation, absorbing excess humidity while releasing it during dry periods. Nature had created an ideal building material that frontier builders ignored. The professor's analysis revealed why Jeremiah's specific design worked brilliantly. The curved chambers didn't just prevent collapse, they optimized convective circulation. Cool air entered low, warmed gradually through contact with temperature-stable walls, and rose to exit through upper vents. The flow pattern created consistent mixing without drafts. Chamber proportions matched mathematical ideals for thermal efficiency that Jeremiah had discovered through intuition and experimentation. Hartley particularly marveled at the breathing wall system. The pine resin and beeswax coating created what he termed a semi-permeable membrane, blocking liquid water while allowing vapor transmission. This prevented both dampness and excessive dryness, maintaining humidity levels perfect for human comfort and food preservation. The charcoal additives created microscopic channels that enhanced breathability. Modern vapor barriers would later struggle to match this natural system's effectiveness. The spring discovery added another dimension. Hartley calculated that water's thermal mass supplemented the clay's temperature regulation. The constant 50-degree flow created a cooling sink in summer and warming source in winter. Jeremiah had unknowingly tapped into geothermal principles, using Earth's stable deep temperatures to enhance his cave's performance. The integrated water system provided benefits that mechanical systems would require complex engineering to replicate. Most significant was Hartley's documentation of energy efficiency. He estimated a traditional cabin required 4 cords of wood per winter for heating, plus whatever cooling attempts summer demanded. Jeremiah's cave used 0 fuel for temperature control. The professor calculated this meant avoiding 8,000 pounds of wood combustion annually, preventing fire risk while eliminating the labor of cutting, splitting, and hauling. The economic advantages alone justified construction effort. Hartley's published report created sensation in engineering circles. European architects studying passive solar design found validation for theories. Mining companies recognized applications for worker housing in extreme climates. Railroad engineers saw possibilities for station construction in hostile environments. The grief-driven innovation of one frontier widower had demonstrated principles that would influence building science for generations. Academic recognition meant little to Jeremiah, but it validated what indigenous peoples had always known: working with Earth's natural properties surpassed fighting against them. Spring 1852 brought unprecedented demand for Jeremiah Fox's expertise. The previous summer's heat wave had converted skeptics throughout Kansas Territory, and now families wanted their own cave dwellings. Rather than guard his knowledge, Jeremiah organized systematic instruction. Every Sunday, groups gathered at his cliff to learn principles that had taken him years to perfect. His teaching method combined practical demonstration with theoretical understanding. The first successful replication came from Thomas Garrett, the former skeptic whose livestock Jeremiah had saved. Garrett owned land with similar red clay formations 2 miles south. Under Jeremiah's guidance, he spent 3 months excavating chambers that followed proven principles. The work proved harder than anticipated. Garrett twice nearly caused collapses by ignoring grain patterns. But persistence paid off. By July, his family moved into chambers maintaining steady 72 degrees. Jeremiah developed standardized approaches for different situations. Not everyone had ideal cliff faces, so he adapted designs for hillside excavations with additional drainage. Some clay formations contained unstable layers, requiring modified chamber shapes. He created templates for optimal proportions, ventilation calculations, and sealing formulas. His notebook of construction principles became a manual copied by hand throughout the territory. The Williamson family project revealed unexpected benefits of community building. Rather than working alone as Jeremiah had, 6 families collaborated on their cave system. Men took shifts excavating while women prepared sealants and managed logistics. Children hauled debris and sorted tools. The shared labor reduced individual effort while creating bonds between previously isolated homesteads. Completion celebrations drew visitors from 50 miles away. Economic implications emerged quickly. Families with cave storage could preserve surplus produce for winter sale when prices peaked. Year-round comfortable workshops allowed furniture making and other crafts impossible in temperature-variable structures. The underground spring model inspired well-digging efforts that tapped previously unknown water sources. Several entrepreneurial settlers began charging for specialized storage, creating the territory's first refrigeration businesses. By autumn 1852, 17 completed cave dwellings dotted the Walnut Creek watershed. Each reflected Jeremiah's core principles while incorporating family-specific modifications. The Martinez family included a chapel space. The Johnsons built connecting tunnels between separate family chambers. The widow Harper created a healing chamber where consistent temperatures aided recovery from prairie accidents. Innovation built upon innovation. Jeremiah traveled constantly, inspecting progress and solving problems. He refused payment, considering knowledge-sharing repayment for community support during his grief. His satisfaction came from preventing tragedies like his family's death. Each successful cave meant children who wouldn't burn in cabin fires, families who wouldn't freeze during blizzards, livestock that would survive extreme weather. The personal mission had become regional transformation. Not all attempts succeeded. Impatient builders who ignored fundamental principles faced collapses. Some sites proved unsuitable despite surface appearances. But failures taught valuable lessons incorporated into evolving best practices. The cave building movement gained momentum as successes far outnumbered setbacks. The winter of 1854 arrived with weather patterns that old-timers called unprecedented. December brought temperatures swinging from 60 degrees to -20 within single days. January added ice storms coating everything with inches of frozen rain. February delivered blizzards alternating with sudden thaws creating flooding. These wild variations tested every structure in Kansas territory, but especially Jeremiah Fox's cave principles replicated across dozens of dwellings. Traditional buildings failed catastrophically. The Henderson cabin collapsed when ice accumulation exceeded roof capacity. The Morrison family abandoned their home when freeze-thaw cycles opened gaps that howling winds exploited. Barn failures killed hundreds of livestock territory-wide. Most tragically, the Walsh children died when their parents' desperate indoor fire spread to walls warped by temperature extremes. Every conventional construction weakness manifested simultaneously. Cave dwellings performed magnificently. The thermal mass that had handled steady extremes proved even more valuable during rapid changes. While outside temperatures whipsawed wildly, cave interiors varied by mere degrees. The breathing walls accommodated pressure changes from storms without damage. Sealed surfaces shed ice accumulation harmlessly. Drainage systems handled snowmelt and rain without flooding. Not one cave dwelling suffered structural failure. The agricultural advantages astounded everyone. Samuel Peterson's cave greenhouse produced fresh vegetables throughout the chaos. His neighbors, buying preserved goods at inflated prices, paid premium amounts for fresh tomatoes in February. Mary Garrett's herb chamber supplied medicines when trails became impassable. Cave-stored seeds maintained perfect viability, while surface-stored supplies froze and thawed into worthlessness. The economic benefits of stability became undeniable. Health differences proved equally dramatic. Pneumonia claimed 37 lives in conventional homes that winter. Cave-dwelling families reported no serious respiratory illnesses. Dr. Hamilton from Fort Scott investigated and concluded stable temperatures and humidity prevented the stress that made bodies vulnerable. Children played actively in cave chambers, while traditionally housed peers huddled around smoky fires. The health advantages alone justified construction efforts. March brought the ultimate test. A late blizzard coincided with rapid warming, creating catastrophic flooding as snow melted onto frozen ground. Entire homesteads washed away. But cave dwellings, positioned above flood levels with superior drainage, emerged unscathed. Families who had fled to Jeremiah's original cave during previous emergencies now sheltered neighbors in their own chambers. The distributed network of safe spaces saved countless lives. When spring arrived, territorial authorities conducted damage assessments. Conventional buildings had suffered 60% loss or major damage. Cave dwellings showed zero structural failures and minimal maintenance needs. The Army Corps of Engineers sent investigators to study why. Insurance companies, previously skeptical of unconventional construction, began offering reduced rates for cave dwellings. Banks approved loans for cave construction while denying traditional building funds. The winter of extremes had provided proof beyond any skeptic's denial. Jeremiah Fox's principles didn't just work in theory, they survived nature's worst combinations. By summer, territorial legislature discussed building codes incorporating cave construction standards. The revolution born from one man's grief had become mainstream acceptance. By 1855, cave dwellings throughout Kansas Territory had evolved from survival shelters into sophisticated living systems. The second generation of builders, learning from early implementations, pushed boundaries beyond what Jeremiah Fox had initially envisioned. Agricultural applications particularly flourished as settlers discovered the cave's potential for year-round controlled environment growing. What began as protection from elements became foundation for territorial food security. The Johnson family pioneered multi-tier growing systems in their expanded agricultural chamber. Using reflected light from strategically placed mica panels and mirrors, they created growing conditions for plants at different heights. Herbs requiring less light thrived in lower sections, while sun-loving vegetables occupied upper terraces. Their February harvest of fresh produce earned more than an entire previous year's wheat crop. Neighbors quickly replicated the profitable model. Commercial applications emerged as entrepreneurs recognized opportunities. William Davies excavated a massive chamber specifically for cheese aging, maintaining perfect temperature and humidity for developing complex flavors. His Quote 16 commanded premium prices in eastern markets. Margaret Thompson created the territory's first florist business, growing delicate flowers year-round in controlled chambers. The stable environment allowed cultivation of species impossible in variable prairie climate. Food preservation reached industrial scales. The cooperative storage company, formed by 12 families, excavated connected chambers capable of storing entire community harvests. Members paid modest fees for space that kept produce market fresh for months. The system eliminated feast or famine cycles plaguing frontier agriculture. Surplus from good years offset poor harvests. Price stability followed as storage prevented dumping during gluts. Medical applications proved equally valuable. Dr. Sarah Mitchell established a sanitarium in specially designed chambers where tuberculosis patients recovered in stable, dust-free air. The consistent environment aided healing while preventing disease spread common in conventional hospitals. Surgical outcomes improved dramatically when operations moved to temperature-stable chambers. The Territorial Health Board documented 50% reduction in post-operative infections. Educational benefits emerged unexpectedly. The Turner family discovered their children learned better in comfortable cave schoolrooms than overheated or freezing traditional buildings. Concentration improved without temperature distractions. Mary Turner established the territory's first year-round school, impossible in structures too hot in summer or requiring constant fire tending in winter. Students from traditional schools showed measurable improvement after transferring. Social transformation followed practical success. Cave communities developed unique cultures, emphasizing cooperation over isolation. Shared construction projects created bonds between families. Connected chamber systems encouraged interaction. The underground springs that many discovered became gathering places. Traditional frontier isolation gave way to interconnected settlements. Crime rates dropped as communities grew closer. Marriage rates increased as young people met during construction projects. By December 1855, territorial census showed over 300 cave dwellings housing nearly 2,000 people. The movement Jeremiah Fox started in grief had become a civilization pattern. Engineers arrived from Europe to study techniques. Agricultural experts documented productivity increases. Social reformers praised community benefits. What had seemed like one man's obsession now appeared visionary. The caves had transcended mere survival to enable thriving frontier society. The transformation of frontier building practices reached beyond Kansas Territory as word spread through 1856. Railroad companies, struggling with station maintenance in extreme climates, sent engineers to study cave construction principles. The Atchison, Topeka, and Santa Fe Railway commissioned experimental stations using excavated chambers for waiting areas and storage. These proved so successful that underground components became standard for desert and mountain installations. Mining operations across Colorado adopted Jeremiah's ventilation principles for worker housing. Traditional bunkhouses near mines created miserable living conditions, freezing in winter, stifling in summer. Cave chambers, excavated using Fox's techniques, provided comfortable quarters that improved worker health and productivity. The Consolidated Silver Company reported 40% reduction in sick days after moving workers underground. Other operations quickly followed suit. Military applications emerged when Fort Riley commanders recognized defensive advantages. Cave fortifications couldn't burn, resisted artillery, and maintained livable conditions during sieges. Army engineers studied Jeremiah's original plans, adapting them for ammunition storage and command centers. The natural temperature stability proved ideal for powder magazines previously vulnerable to heat-induced explosions. Western forts increasingly incorporated underground elements inspired by civilian cave dwellings. International interest grew as immigrant communities wrote home about revolutionary housing. Norwegian settlers, recognizing similarities to traditional mountain techniques, sent detailed descriptions to Scandinavian newspapers. German engineers requested construction manuals through consular channels. A French architectural delegation spent months documenting various cave installations. Japanese visitors studying American railroads became equally fascinated by cave adaptations for extreme climates. Educational institutions formalized the knowledge. The Kansas Agricultural College established a Department of Earth Architecture in 1857, the first academic program studying indigenous-inspired building techniques. Professor Hartley, who had first documented Jeremiah's achievement, developed curriculum combining geological science with practical construction. Students learned thermal dynamics, excavation engineering, and moisture management. Graduates spread expertise throughout expanding territories. Commercial standardization followed academic recognition. The Prairie Building Supply Company began manufacturing specialized tools based on Jeremiah's designs. Pre-mixed sealing compounds matching his formula became available. Ventilation components were mass-produced using proven specifications. Construction manuals sold nationwide. What had required years of experimentation became achievable through systematic instruction and proper equipment. Urban applications surprised everyone. Kansas City developers, facing expansion constraints, experimented with partial underground structures using Fox principles. Commercial buildings incorporated basement levels, maintaining year-round comfort without heating or cooling. Breweries discovered cave chambers perfect for fermentation and storage. Hotels advertised naturally climate-controlled rooms. The technology initially dismissed as primitive proved sophisticated enough for modern applications. By 1858, Fox construction had become standard terminology across multiple industries. Architecture schools taught courses on thermal mass utilization. Engineering firms specialized in underground design. Banks financed cave projects, understanding their durability. Insurance companies preferred underground risks. The revolution sparked by tragedy had transformed American building practices permanently. Yet Jeremiah Fox himself remained focused on individual families, traveling constantly to help newcomers create safe homes. Jeremiah Fox entered his sixth decade as 1860 approached, his hair white but his passion for helping others undiminished. The man once mocked as grief-crazed had become Kansas Territory's most sought-after building consultant. Yet fame meant little to him. He continued living in his original cave, making modest improvements, but maintaining the simple lifestyle that began with tragedy. His satisfaction came from letters describing families safe through storms that would have destroyed conventional homes. The original cave had evolved into a teaching laboratory. Jeremiah added demonstration chambers showing various construction techniques. He created cutaway sections revealing wall composition and ventilation details. The underground spring fed an expanded pool where he taught drainage principles. Most importantly, he maintained detailed records. Temperature logs, spanning 12 years, proved the consistency that skeptics had doubted. These measurements became baseline data for scientific studies. Personal life remained solitary by choice. Several widows had shown interest in the prosperous consultant, but Jeremiah politely declined advances. His dedication to Elizabeth and Mary's memory never wavered. The cave held too many evenings spent designing their protection, too many moments when grief drove innovation. He found companionship in teaching and community service rather than remarriage. Students became his extended family. The approaching Civil War created new demands. Military strategists recognized cave fortifications' advantages for border defense. Jeremiah consulted on defensive positions, adapting civilian techniques for military purposes. He insisted on non-combat applications, field hospitals, supply storage, prisoner housing that maintained human dignity. His influence helped establish humanitarian standards for military construction. Even war couldn't corrupt principles developed from personal tragedy. Recognition arrived from unexpected quarters. The Smithsonian Institution requested his papers for preservation. European universities awarded honorary degrees to the self-taught engineer. The territorial governor proclaimed Fox Day, celebrating innovation born from adversity. Jeremiah accepted honors graciously, but immediately redirected attention to ongoing work. Ceremonies meant less than another family moving into safe quarters. Health concerns emerged as decades of physical labor accumulated. Arthritis from years in damp excavations limited mobility. Lung scarring from clay dust created breathing difficulties. Yet Jeremiah continued teaching from his chair when unable to demonstrate personally. Younger builders he'd trained carried on physical instruction, while he provided guidance. The movement had grown beyond any individual. His final major project came in 1862, designing a community shelter capable of protecting entire settlements during warfare. The massive excavation required 200 workers and revolutionary engineering to prevent collapse. Multiple entrances prevented siege tactics. Independent ventilation systems ensured survival if sections were damaged. Storage capacity could sustain 500 people for months. The project demonstrated how far cave construction had advanced from one man's desperate excavation. By 1863, Jeremiah Fox had transformed from active builder to elder statesman of underground architecture. His influence spread through hundreds of successful implementations and thousands of trained practitioners. Yet he remained the humble craftsman who discovered truth through tragedy. Jeremiah Fox died peacefully in his original chamber on April 3, 1867, exactly 20 years after losing his family to fire. He was discovered at his work table. Plans for improved ventilation systems spread before him, having passed while still innovating. The funeral drew thousands. Families whose lives he'd saved, builders he'd trained, officials recognizing his transformation of frontier architecture. They buried him beside Elizabeth and Mary, together at last. The cave that had seemed like madness in 1849 stood as monument to vision born from grief. Territorial surveyors documented its condition. After 18 years of continuous occupation, walls remained stable, systems functioned perfectly, and the famous thermometer still read 69 degrees. No maintenance had been required beyond occasional resealing. The structure, engineered to last decades, would clearly survive centuries. Scientific analysis continued advancing understanding. The University of Kansas established permanent monitoring stations in various Fox-designed caves, documenting performance across decades. Data confirmed what experience had proven. Thermal mass combined with controlled ventilation created optimal human habitat using zero external energy. Researchers calculated that widespread adoption could eliminate most heating and cooling needs nationwide. The implications for resource conservation staggered contemporary thinkers. Modern applications proliferated beyond Jeremiah's imagination. The Transcontinental Railroad incorporated underground stations throughout mountain passages. Agricultural communes used cave systems for year-round food production. Hospitals built surgical suites in temperature-stable chambers. Wine regions excavated aging caves based on Kansas principles. Each application validated core concepts discovered through frontier necessity. International influence expanded as America's reputation for innovation grew. Japanese architects studying earthquake resistance found cave construction naturally dampened seismic forces. Australian settlers facing extreme heat adopted techniques for outback survival. Norwegian immigrants recognized sophisticated evolution of traditional methods. The knowledge freely shared by one grieving man spread worldwide, saving lives across cultures. Preservation efforts began immediately after Jeremiah's death. The Kansas Historical Society declared his cave a territorial monument. Engineering students maintained the structure as a living laboratory. Families he'd helped established an education fund training new builders. The original construction manuals were printed and distributed free, honoring his refusal to profit from life-saving knowledge. His legacy lived through principles rather than patents. Archaeological studies in subsequent decades revealed the sophistication of Jeremiah's achievement. Computer modeling showed his intuitive designs matched optimal mathematical solutions. Materials analysis confirmed his sealant formula exceeded modern equivalents for longevity. Ventilation patterns followed fluid dynamics, principles not formally understood until the 20th century. The grieving widower had achieved through observation what trained engineers derived through calculation. Today, thousands of structures worldwide incorporate Fox principles. Modern sustainable architecture recognizes him as a pioneer who proved humanity could build in harmony with nature. Climate change makes his innovations more relevant than ever. The cave maintaining 69 degrees without fuel stands as testament that necessity drives innovation. Grief can transform into gift, and one person's obsession to prevent tragedy can revolutionize how humanity shelters itself. In red clay chambers across continents, the temperature holds steady and the walls still breathe.